Welcome to Hallicrafters Rehabs. Thank you for new subscribers, and we're in part 3 of the SX-99 rebuild, and I've been spending a number of hours cleaning up this chassis here, and it's got stains in it and still, they're not pits, but it's just not going to clean up to the standards I'd like to see if I were just going to have this as a surface. So I'm pretty sure I'll be painting this, but not now because the weather's not good. It's cold and rainy out there, and we need kind of like a sunny day. I do have heat here, but I don't want to, you still need to have some good weather outside. And it's not ready to paint, it's not prepped. And one thing that we do is we're going to have to put in the holes or penetrations in here. One for the antenna. I'll put one in for, I like these bayonet fuse holders because you really don't want to be opening up this thing to get inside to get a inline fuse, and what a mess that would be. And I don't like the Hammerland idea of putting a live fuse on top of this chassis. So we drill a hole for that one. And here's a Molex connector, which I'll be putting in somewhere in here for the purpose of providing power and signal to a frequency counter. And so I did decide to test this electrolytic. This is a Mr. Carlson's Lab early version low voltage capacitor checker. Let me get the leads out here. And everything's all tangled. You know about the wires. Okay. So, for example, here's a 10 microfarad capacitor inside the can. We'll attach it here, and what you turn it on, it will turn blue and then fade to black if it's in good condition. It's set on electrolytic, and there you see, and it's actually charging. So isn't that amazing? You probably could reform this if you want. If you want it, you can pay the postage and I'll send it to you. I'm not going to use it. Here's another 10 inside the can. And looky there, it's a lot slower. There you see. Yep, gotta be fast. For comparison, I have a new one here. See how fast it charges. And whether it's, oh, it's already done. Well, actually, I cheated. Oh, here we go. There we go. That's what's going on. All right. We're all charged up in just a few seconds. So, not exactly a good capacitor. And then I decided to pull that one of that tiny chiefs out. I knew what the answer would be here. I'll set this for a regular capacitor here. And we'll look for the blue to go out some year. It's basically turned into a resistor, as we all know that tiny chiefs do. So even though the electrolytic would probably work just fine without any noise, these tiny chiefs, and which tells me it's not a lot of hours on this thing. Here's a good capacitor right here, so we'll test that. And look how fast it charges up. No leakage at all. So there's your difference between a good capacitor and a bad capacitor. And also I did decide to go ahead and test, ohm out this power transformer. I'd never done the primaries, which we can do right now. This is going to take some cleaning up and so forth. It just is, I'm not sure which one of these two it is. That's not it. Okay, I'll get the right one pretty soon. Okay, this one is the secondary. Let's find that one. Okay, so these two are the primaries. I'm trying to get them to even do a good contact as a, there we go. 5 volts, 5 ohms. So we have a good primary, but I'm wondering about, I may have to do some resoldering inside there because it doesn't want to always ohm out quickly. It's very, very nasty wires there. Okay, so we'll be putting in those, drilling in those penetrations. You do not just stick a drill in the back of these things. You have to plan. I have actually drilled a hole in an antenna coil doing this kind of thing. So we will be, to get this in here, we'll be taking all of this out and going ahead and reconditioning this section, antenna section, with everything out of it. We do the drilling. And here we're kind of cleared away for that Molex connection. And over here we're pretty much cleared away, so we won't have any issues. I have removed, I've gone ahead and removed these because I don't want to, when I was cleaning, I didn't want to lose the lettering and all that kind of stuff. I can spend a little time cleaning this up with it without losing the numbering system on those terminals. So that's where we are right now. We'll be putting those holes in. And we won't just sit and wait. We can actually start work on the electronics inside here. I've removed these just to, because when we paint, we will be prepping it this way. We'll be taking this out, and we'll be taking that out before we paint. It'll just be a clean prep for painting. So actually there'll be a break here of a few days because I go and take care of my 99-year-old father for a couple days, and then we'll continue with this same episode. Oh, as a note, to clean up this chassis, I used a number of different things, not advocating one over the other, but sort of. Nobody gives me any money for this stuff, but anyway. Probably the least effective is Ajax, which is stronger than dirt, but not much stronger, not very strong for chassis. A good one, this Resolve stain remover, probably contains soap in it, so it was a combination of cleaning and it was stripping some of the rust as well. Ollie OxyClean was okay, but not the best. 409, in Canada it's Vim, same formula. And that did a pretty decent job. Windex, and 91% is the best we can do in isopropyl alcohol was what I finished it off with. So, but I got the shine basically using 1500 grit and 2500 grit wetted with this alcohol. So on a better chassis than this, that would have a really nice result, but this one is just, we could take one more stab at it when I've got the sockets out. You have to have a nice, clean way of doing this. I don't. So I'm still looking at painting. But really using that 1500 grit and 2500 grit, it's nothing more than polishing sandpaper anyway. Wetted with alcohol was probably the most effective cleaning agent after using navel jelly. First navel jelly and then finishing it off that way. So that's how I got there. Okay, so I've also switched to my high-powered reading glasses, and this has made a huge difference. Sitting there trying to see what I can't see. Now I can see my mistakes happening instead of wonder what happened. Okay, we're just going to click that. It's just not worth it. There we go. 1 meg ohm resistor. Okay, so now I can see what I'm doing here, and we can get this out without damaging that tube socket, hopefully, or the mica capacitor. I have new mica capacitors. I might use them, and then I might not. But I don't have the option. If I mess up this one, then that's all there is. This is new. Okay. Let's turn around. We just need to pull it out. There we go. So that's free, not free, 22 ohm resistor, that's free, that is connected to a ground, and we'll be getting rid of it anyway, so I'm not going to worry about that. Free. You must be wondering what I'm getting ready to do. We're going to pull everything out. That's what I'm getting ready to do. Time to try, do a test try on what we're planning to do here. One Dremel. All right. Here we go. I told myself to put safety glasses on in my head, but I didn't execute. Okay, back to the well, there's the other end of that bit. A lot of loose things under here. Yeah, loose everywhere. That comes out like that, see? Isn't that nice? And we can put this right back on it so we don't lose it. Beginning to see what's going on here, huh? Okay. We still have these sockets attached. Looks like all of these things came loose from the bottom, which is kind of funny. Let's see, that one is like open heart surgery. No, it ain't. The radio equivalent, maybe. The radio equivalent of open heart surgery, which is nothing like real open heart surgery. Okay, so that's loose. Everybody's loose. He's soldered in there, so let's put that up. That's it. It's loose. Okay. Am I nuts? Yes, I'm nuts. Always wanted to do this. Look at it. This is the perfect radio for me to do it in. A third restore like this. Oh, we got another connection over here. Let's see what that is. Just the ground or something. Can't be the ground. Oh, that's the switch, of course. The switch is going to connect to the primary on the transformer. There we go. Alright, that's the other part of the switch. Okay. Alright. Everybody's loose. Are we nuts? Yes. Are we crazy? Yes. I'm going to take these screws all the way out of the transformer. Okay. Transformer's out. This is out. Everybody is out. Oh, looky here. Have you ever? Yeah, that's this. Completely freed the power switch and the volume control. I think there was a Okay, yeah, that's the volume control went to the output of a 6K6. Okay, that's interesting. Oh yes, the AVC is, oh, but we're not doing it. Let's go ahead and click this. That is a capacitor on death row. All right, so we're just sliding that right through here. Just leave it as close to wired up as possible. That's just like a visual cue. Make the wiring back a little faster maybe, or not. Because this is not going to go. It's not enough clearance. Boy, look at all the parts raining. So, in that case, clip and clip. So, that's the sensitivity in AVC. And looky. Have you ever? I bet you thought about it though, haven't you? Okay, we're going to put this in a plastic bag. Why not? It's still kind of wired together. Be nice and easy to clean now, huh? Okay, I'll be back in a minute. Okay, well, I'm kind of surprised at how well that bagged up a little bit with all those sharp corners and everything. Just lay that to the side, and now we're going to go to work on this switch, because we're going to clean this switch and recondition all of this up into its into its wonderful condition it will be in, needs to be in. And then this allows me to really get under where those tubes are, and there's a little bit of crud and things like that. There will be no rust coming up from that part. And there's some 2 screws around here somewhere I want to put in that. Alright, we'll do that later. So now we have the switch, and we're going to desolder that switch. And then we can get in and we can unscrew this and get on that side to clean that switch connector. So here we go. And this has a WGN attenuator, 1000 ohm resistor in series. So we'll have to I always bypass that. I'll just go ahead and put a jumper instead when the time comes. I don't want any attenuation on any band. That's just me. Okay, if I forgot, I wasn't listening. It's clogged up. Okay, yeah, you can. It's going to be time to clean the whole thing out pretty soon. Alright. Here we go. We have a color coding system here. So this is switch position 1 for the input. What you have is the signal comes in here to this blue, and it comes in on the other side, which will connect with, this is band 1, band 2, band 3 has got no color code, and band 4 is this one over here. Now there's two coils on this one form, one for band 1 and 2 over here. Then there is, I gotta get used to doing it this way. There's just one, this is band 3 right here, and then this is band 4. So we're just gonna we're gonna use that color code. This uses solid wire. I might just go ahead and replace it because it's easy to do. because we're going to get to the switch anyway. But I like the idea of using color code for each band. I see a lot of rosin on this thing. We're going to clean that off. Take it outside and clean it with paint thinner. Be nice and pretty. To band 4. And then this is ground. We don't even have to remove the ground. Okay, so let's see if I can have any luck. Now that resistor, I don't even want to save. We're not going to have an attenuation of the signal. So it goes out. Now band 2 is just a jumper. And it's yellow, and I want to remember that it's yellow and use a similar, let's get this, use a similar color coding. I think I have to use my, right. We have to put this up. We're using the soldering iron at this point. I'm going to have to stop and do a cleanup pretty soon. It gets pretty hectic in here when I'm working. Get this under here. Should be able to twist that around and bring it out, and it did burn the clean on a little bit. Clean that as best we can. I'm only doing this one to get it out of the way. And why don't we use the one that I have to get out of the way first, which is band 4. All right. I think we're pretty close to being able to just remove the whole assembly. So let's take a look at it. That's one. I've done this before. That's 2. That's what I did. As you can tell, I got to put my head in here. Looks like it's flathead. Let's be inconsistent, shall we? It is. So we have the wire coming through here and here that prevents it from coming out. Well, guess what? They're going to get clipped. It would be better for the coils to put new ones in than to attempt to. Here we go. Ah, yes. And same thing with this. That's definitely a clip. Okay. We're going to put in actually solder. It's connected here. Oh, yeah. I'll put that in too. And keep the color coding. I don't know what goes to what. Okay, what's top now? Screw still in there? It surely is. It is a screw that has a nut on it. Don't we love that? Okay. Of course. All right. Do a tour here. Okay, so that's obviously a band 4. Here we go, get in the camera. This one is obviously a band 4 coil. Band 3, these are just antenna coils. Now, the band 2 will be this one down here, just the one set wound around. These look in good condition, so I'll have very little work to do with them. We'll go ahead and test them. They're going to ohm out. I could just see the connections are still there. Well, you never know. There can be stuff inside, but it looks. Move this around to where the camera is. Well, we can actually move back it off a little bit. So they look in good condition. Yeah, I don't see any obvious breaks. So, take this flathead screwdriver, bring it through here, and remember the nut. We've got, this is the screw that belongs. This is a screw that belongs up in here where the crystal phasing control was. I'm just putting it back into the chassis so I don't lose it. Okay, these are the Phillips heads that go in and anchor the. Where is the other Phillips? I think it rolled around and deep inside this chassis. I'll have to shake it out in a second. Just cleaning up a little bit. All right. So that's going to go in a bag. See if I can get this out of here. I don't know where that. There it is. It popped out. So we're going to have to spend a few minutes cleaning up this absolute wreck and bagging the antenna section here. Be right back. Okay, so I removed the antenna section in here. 2 were Phillips head and 1 was a flathead. I did have to clip. This is band 2, that's band 1. And you can tell by the switch 1, 2, 3, 4 which one it is. And we bagged that. They looked in good condition. They don't seem to have any obvious breaks or anything in them, so that's good. This obviously came out as nothing but a ground to the antenna gang section of the main tuning gang, and we will be replacing that with, actually it's easier to work with, solder wick, and shrink wrap. Alright, to remove this one, we're going to have to remove these slugs. There are screws under them. This one is just a ground. We're going to clip that, but when it goes back, I'll know that that connects because it's right next to each other. These I'm going to replace with ceramics. Okay, we're in the RF section. I've removed these slugs and clipped wires in almost every place. This one I want to save this capacitor if at all possible. The resistors are less important, but how we will get that done is a little tricky. I can remove this. Okay, we now have a clean desoldering iron, and I didn't burn myself. That was amazing. And so we'll now see if we can get this capacitor loose. Yeah, it works great when it's clean. Yes! Success. Okay. Now, it leaves just the removal of the screws, which are Phillips, and of course, this belongs on the other coil. That came out. Yep. He's a flat screw in that. Okay, one, two. This way. Please. Just meet you. Okay. I'll use that part, please. Okay. You guys need to run that. Okay, that out. Three. Put that. Okay. Okay, so that's wrapped around there. There we go. Yeah. I thought I clipped that. I didn't. All right. Let's put that nut back. Okay. I ran down all the parts that escaped my hands, except that one. That's a Phillips head screw. And this looks in good condition. Pretty much the same, similar kind of coils, obviously. It all has to do with inductance, and we'll be doing all those measurements later before we put them back in. So I'll get this inside a plastic bag, and we'll be ready to move on and tackle the oscillator section, which will be interesting. Looking at the oscillator section, this definitely will be fun. We've got 4 coils forms this time. So that adds more to the equation for sure. That's attached to the switch. I can't believe that is in the oscillator section. We won't be using anything close. We'll be using an NP0 for that. Okay, and hopefully we're going to get much better drift results. So, that's just a 10 ohm resistor. I got 100 of those. We'll just preserve the and then this one too. Okay, now we're going to have to remove those slugs like we did on the other. I need to put these slugs in with the other coils. Okay, here we go. Yes, this will detune everything, but then again, everything I'm doing is detuning everything. Virgil. Band 4 comes out rather easily. Yeah, it's connected still. We have the lower one. All right. That makes it a lot easier to get to the rest. I'm gonna just cut that lead, use it as a guide to putting it back in. And a more yellow one in the bottom here. Let's put this up. Probably. I'll just do it. I'll clip that too. That helps me remember what goes where. Okay. All right. In this complex of coils, so I think we got what we need. I need to go bag this up. We've got this all cleaned out. And switch cleaning will not be today. And we'll be able to take this out on everywhere else and clean that switch. Okay, we need to go run off and get a bag, and then we'll be back. So I got a little jig here. See if I can get it in the camera shot. Here we go. With the vise that will allow me to drill the holes. Okay, folks, we have our holes drilled. One for the frequency counter, a fuse, and I checked the clearances, that'll be okay. And this is real short, so it won't be a clearance problem. That's the antenna connection. So next is to work on this chassis some more, clean it up some more. I have some astronomy mirror surfacing grit on the way. I'll demonstrate. I don't know if it'll help or not, but we'll give it a shot. And then we have the switch cleaning, and then we start putting things back together. Yeah, that's the Hallicrafters rehabs. And this is Albert. Thanks for watching.